The topic that has gained particular popularity, in the recent years, is the topic of stem cells. Stem cells have fascinated scientists for a number of reasons, as they can find many applications in many different fields of medicine, as well as basic research in biology, but they have yet to realize their real potential. So before we actually see some of the applications and find some of the pitfalls that befall stem cells, it's worth looking at what stem cells are and the different categories of stem cells that we have, which is something that you need to know for the exams. So stem cells, unlike the rest of the cells that we have in your body, are undifferentiated, which means that they are, if you want, ancestral forms with no specific shape, and they have obviously the capacity of repeated cell division, therefore they're not terminally mature. Now, what differentiates stem cells is their ability to divide into other cell types. All of them are undifferentiated, but that doesn't mean that they can give rise to all different other cell types. We have embryonic stem cells on one hand, as you can see here, and then we have the adult stem cells on the other hand. Now, embryonic stem cells, as the name suggests, comes from the embryo, and they have the ability to differentiate into all or almost all of the 200 different cell types that we have in our body. Hence, their potency, useful to remember these terms, is pluripotent or totipotent. Totipotent have the ability to differentiate into all 200 different cell types, while pluripotent have the ability to differentiate into all of the cells that give rise to an adult, like you and me, but they cannot differentiate into the cells that make up the placenta, if you want, and the amniotic sac of the embryo. So they are pretty much, for practical purposes, equivalent to totipotent stem cells. Now, adult stem cells can be found in adults, obviously, and unlike embryonic stem cells, are multipotent, which means that they can only give rise to very limited number of different cell types. Things of the bone marrow that it can give rise to red blood cells and white blood cells, but nothing else apart from that. Right. So, moving on to where can we actually get stem cells from? Now, embryonic stem cells can be obtained from a variety of sources, but primarily they can be acquired from spare embryos following IVF. Now, IVF stands for in vitro fertilization, which is a procedure of artificial fertilization of an egg with a donor sperm, and you probably know that the zygote is then transplanted into the womb of a surrogate mother. So a lot of these fertilized zygotes, we have a plethora of them which are not actually implanted into the female's womb. So those that would otherwise go wasted, they can be used to get stem cells from embryonic in origin. At the same time, you can safely remove one cell from the 8-cell stage during prenatal genetic diagnosis. That's what PGD stands for. So basically, once you've fertilized the egg with the sperm and you've got the zygote, this starts dividing. Before implantation, scientists usually leave it to multiply a number of times to check if everything is going all right, and then they implant it into the female's womb. Now, you can, and I'll show you what I mean, you can actually, that's the process of in vitro fertilization, and then here you can see this zygote, which has undergone a number of cell divisions. You can see it here. Let me change the color so that it becomes more obvious. So here, right, that's the zygote, which has undergone 4 divisions, and therefore you've got 8 cells making it up. Now, if you remove one single egg from this mass, the rest of the embryo can be implanted successfully to the female and can give rise to a healthy individual. So back to the slide where we had the different sources of embryonic stem cells. They can be, as I said, spare embryos, whole zygotes that would otherwise go wasted during IVF. They can be a single cell removed from these zygotes that have been left to divide for 4 divisions, or they can be, once the baby is born, from the umbilical cord or the amniotic fluid. Now, adult stem cells, we have small populations of adult stem cells in all of our organs. The most classic example that most people know of is the bone marrow, but having said that, all organs have small populations of stem cells which are there to allow the tissues to regenerate following an accident and so on. One exception is the neural system, which, as you probably know, if it gets damaged, then it cannot get replaced, and this is why, for example, you're left paralyzed after an accident of the spinal cord. So, moving on to the advantages and disadvantages of the 2 different sources of embryonic stem cells, of stem cells, I'm sorry. Obviously, the main advantage of embryonic stem cells is that they can give rise to pretty much every cell type that one would like to use in an application. They're easy to extract during in vitro fertilization or pre-implantation genetic diagnosis, and they're easy to culture, therefore increasing numbers. However, there are a lot of ethical issues associated with embryonic stem cells because, in essence, these zygotes, these fertilized eggs, if you want, they could, if allowed, become babies. And therefore, what we're actually doing there is killing babies if they were allowed to grow, or if they were implanted to a surrogate mother. At the same time, people that actually need stem cells for, let's say, they had a severe burn of the skin and they need a lot of cells to make new tissue to replace this, then if they haven't kept their own cells and they utilize stem cells from another donor, then there are issues with histocompatibility and therefore, as you can see here, rejection issues. Okay. Now, one other problem is that basically 2 more drawbacks of stem cells. These 2, the risk of cancer development, the risk of infection. This is something that embryonic stem cells share with adult stem cells, in that whenever you have a stem cell and you need to culture it to increase in numbers, and then you need to differentiate into a cell that you can actually use for an application, you provide the cell with a lot of growth factors and you use its division. Therefore, it's easy to lose control, and losing control in a very tightly regulated cell cycle usually results in the development of cancer. So this is a problem that stem cells, embryonic and adult, share in common. At the same time, in order to actually use the stem cells, you're gonna have some form of operation, and therefore there's always the risk of infection, although that is the least of our worries when it comes to stem cells. Now, adult stem cells, when compared to embryonic stem cells, since they are acquired from the individual himself or herself that actually needs these stem cells, there are no rejection risks to be avoided. There are no histocompatibility issues, if you want, and there are a lot fewer ethical issues. However, it's very difficult, and that's what you need to remember, to extract them. For example, taking a bit of bone marrow from or spinal fluid from the spinal cord is a very painful and very dangerous operation, which should be avoided at all costs unless we know that it's going to be successful. And therefore, a lot more difficult to extract than embryonic stem cells. And being multipotent, unlike the embryonic that are totipotent and pluripotent, it's difficult to produce different cell types, so they have very limited applications. Right? When it comes to the actual applications of stem cells, they can be cultured to increase in numbers, and then they can be differentiated into, say, neurons. So we could, in theory, treat Parkinson's disease by implanting neurons where they are needed in the middle of the brain. We could restore this insulatory layer that neurons have, the myelin sheath, and treat multiple sclerosis. The same holds true for severe damages of the spinal cord and brain damage. As we said, these cells are usually terminally differentiated, therefore there is no backup plan. If they are damaged, that's it. So with stem cells, we could, in theory, regenerate damaged nerves. We could produce organs, right? You must have heard of 3D printing, which is used now, but it should be, in theory, a lot easier with stem cells. And burns, as we already discussed, of the skin and so on. So the applications are numerous. However, because of the pitfalls and the drawbacks that we discussed in the previous slide, primarily the risk of developing cancer, stem cells have not yet realized their full potential, and it's unlikely that in the near future they will live up to the expectations of the scientists. Needless to say, ethics, which is something that Britons are very keen on, you should know, I mean, the most important thing that you need to remember when it comes to ethics is that there is no right or wrong. You can, as long as you're able to provide some arguments to back up your opinion, that's fine. So you're not going to be marked down for saying that you're against the use of stem cells, which is a bit controversial, but still, if that's your opinion, it's fair enough. As long as you provide the necessary arguments and you know what you're talking about. So the idea is, and my suggestion, that you come up with both arguments that are for stem cells and some arguments that are against, and then making a complete answer in the form of, I'm against for this and this and that reason, but I'm pretty sure that there is some good to be found in stem cells because of that. So always provide a balanced answer for scoring top marks. Now, if we actually examine the actual ethics concerning stem cells, as you would imagine, for those people that are for, the blastomeres, remember the cell stage, cannot be granted the same respect as a fully grown human embryo. And if you remember, there are a lot of spare embryos being fertilized and being created during in vitro fertilization that would be destroyed otherwise. However, the people that are against that claim that all zygotes, even a single cell, should be granted equal rights to survival, if you want. Therefore, they are humans if they were allowed, and life is sacred and so on. So they shouldn't be destroyed in order to acquire stem cells. Now, an argument is, if you remember, that we can remove one cell from the 8-cell stage without harming the mass, which can then get implanted in order to give rise to a baby, and no death is caused. However, again, there is an argument against it, that we shouldn't tamper with nature. We should leave it as it is. Children, for example, parents, or it's the same sort of argument like for those couples that cannot have a child. If nature didn't make them capable of having a child, then they shouldn't be allowed to have a child. That's the same sort of argument here. Finally, the advancement of knowledge that we can get from stem cell research in many scientific fields, treating infertility, different health conditions, and so on. The argument against that is hard to find, but yes, it does require expertise and expensive technology that require expenses to be made, expenses that could be directed into different I don't know, for example, the third world, that sort of thing, find better uses that could change the life of many different people. So that's it as far as stem cells are concerned. What you should know for the exams are what they are, the definition, the different categories where we can obtain them for. There are advantages and disadvantages when it comes to embryonic and adult stem cells, and some ethics concerning their use. Thank you.